Hello Year 4, welcome to part 2 of today's maths lesson. On the slide here I have got a multiplication that says 5 multiplied by 28. What I would like you to do is in a moment pause the video and decide which strategy do you think is going to be most efficient for working out this multiplication. Do you think you're going to partition your biggest number? Do you think you're going to look at the factor pairs of a number? Or do you think you're going to use a strategy of doubling one factor and halving the other? Can you pause the video please, think about which strategy you're going to use and find out the answer please. Off you go. Okay, so let's start with looking at the answer. So the answer is 140. Well done if you got that one correct, and let's look at how each of the ways would find 140. So for the first one, looking at partitioning, we know we can partition the number 28 into tens and ones. Can you please tell me how many tens does the number 28 have? 2, fantastic. So we would partition it into 20, and what else will we partition it into, Year 4? 8, fantastic. We can partition 28 into 20 and 8. We can then work out the first step, which would be 20 multiplied by 5, or 5 multiplied by 20, giving us the answer of 100. We could then work out 5 multiplied by 8, giving us 40. Now what do we need to do with these two numbers now, Year 4? We need to add them. 100 add 40 is 140. So that is the first way of working this one out. The second way is looking at the factor pairs. Now, if we wanted to look at the factor pairs of 28, can you give me some examples of the factor pairs of 28, please? Just tell the screen and call them out when you're ready, please. Off you go. Well done. I can hear lots of you saying maybe you could look at the factor pairs of 28 being 2 and 14. So that is an example of one factor pair. We know always that if we get 5 and 2, we can group them together to make 10. And our new multiplication would be 10 multiplied by 14, giving us 140. But we could also look at different factor pairs of 28 being 7 and 4. We could then group together the 5 and the 4, giving us 20 multiplied by 7. Now if we know that 2 multiplied by 7 is what, please? 14. We can then multiply that by 10, giving us 140. The final way that we could work out this one is using our rule of doubling one factor, halving the other, making sure that the product always stays the same. So, if you've done this one, which factor have you chosen to double and which factor have you chosen to halve? Tell the screen, please. I think I would have done that too. What I would have done is I would have doubled the 5, because we know that we can double it to make 10, and halved the 28, giving us 10 multiplied by 10 multiplied by 14, which is 140. I've got another multiplication down the bottom here for you, 6 multiplied by 15. Does it matter which factor you choose to double and which factor you choose to halve? Have a go with this one and let me know your thoughts, please. Pause the video. Okay, well, we can halve the number 15, but then we'd be getting it into a bit of a tricky mess, because 15 halved, does anyone know? Well done, it is 7.5, and that makes it a bit tricky to multiply with. So I think in this circumstance, what we'd have to do is double the 15, and that would mean halving the 6. And our new multiplication, if you've got this right, fantastic, would be 3 multiplied by 30, and we know that 3 multiplied by 3 is what, please? 9, and then you add the 0 on the end. You don't always have to do doubling and halving though, because as long as you do the same to one factor and then do the opposite to the other, you will always get the same product. So I've chosen here to divide 6 by 3, but which means I wouldn't divide 15 by 3. What would I do? Would I double 3? No, I wouldn't. I'd multiply that by 3, which would give us our new multiplication of 2 multiplied by 45. Which is the same as 45 doubled, giving us again 90. Now your task for today, I know some of it's cut off down the bottom and I apologise for that, but it will be in your resource pack anyway. I would like everyone to be completing this sheet, please. When you've done this sheet, all you need to do if you can't print it off is just write 1A, 1B, 1C on a piece of paper, and you can send that in to the office. When you've done that, I have been giving you last week some of these extension sheets, which are all around reasoning and problem solving. I don't expect you to do both this strip of paper and this one. The idea is year 4 that 4A, 5A and 6A, you choose whether or not to do these 3 or these 3. 7A, 8A and 9A are a bit more challenging, so if you start off with the challenging ones and they're too tricky, that means you can move to these ones and they'll be a little bit more easier for you. What I don't want to see though is you just giving me one word answers. We know, don't we, that when we have a problem solving question, we need to explain why we think this, or why it's correct, or why it's incorrect. With these ones, we might want to explain why we'd use this method, because it's more efficient. How is it more efficient? So on the resources, I have explained again that 4A, 5A and 6A are the slightly less challenging ones. I would like you to see lots of children trying the challenging ones, but also when you've completed those, send them into the office and they will pass them on to me. I love seeing all your work so far, so thank you to those children who sent it in. I really look forward to seeing your maths work today. Well done for some great listening. I know it was a little bit longer than usual, but I will see you in our next lesson. Bye, Year 4.